Hello folks, and welcome to Solving Equations with Rational Exponents. So today we're going to solve equations again, but they're going to start out looking a little bit different. They're going to have that exponent that has a fraction, and so I don't want you to let that freak you out. We'll be just fine. If you take out your notes, a pen or pencil, and a calculator, we will get started. Now remember what we talked about yesterday in solving equations. We're always trying to get that x variable alone. So when we do that, we use those inverse operations that we also talked about yesterday. And don't forget to check your work. All right, so let's go ahead and do problem number 1. It says x plus 2 to the 1/3 power plus 3 equals 7. Now this looks complicated and scary, but remember what we learned at the beginning of chapter 6, that we can take rational exponents and turn them into radical form. So remember, this was the index, and so the index here is a 3. So therefore we would have the cube root of x plus 2 plus 3 equals 7. Now this looks just like we did yesterday. So if we take our problems and turn them into what we saw yesterday, these won't be so bad. So the first thing I would do, okay, well I'm trying to get this alone, so I can't touch that if that's what I'm trying to get alone. So I'm going to subtract 3 on both sides. I have the cube root of x plus 2 equals 4. I am then going to do the inverse of cube rooting, which is cubing. I'm going to cube both sides, and I'm going to get x plus 2 equals 64. Then I'm going to subtract 2 from both sides, and I'm going to get x equals 62. And now I'm going to plug it back in and make sure that it works. 62 plus 2 is 64. If we look at our yellow sheet, that handy dandy yellow sheet, the cube root of 64 is 4, and 4 plus 3 does equal 7. Therefore, our answer really is x equals 62. All right, let's try another one, which might look a little bit more complicated, a little scary here. We've got 3x to the 2/5 power minus 12 equals 0. Well, this is what we're trying to get alone, and that looks kind of scary. So let's go ahead and rewrite it in radical form. This would be the 5th root of x, all of it squared. And that's being multiplied by 3 and subtracted. We're subtracting 12 there, and that equals 0. So the first thing I would do is turn it into a radical and then go, okay, I need to get this alone, so how do I get rid of all the rest of this stuff around that x? Well, the first thing I'm going to do is add 12. So I have 3, the 5th root of x, that's being squared, equals 12. Okay, now I want to get this alone, so I'm going to divide by that 3. So now I have the 5th root of x squared equals 4. Okay, now I've got to do a couple of inverse operations. Notice in the last one I just did one inverse operation when I got to the radical. Now it looks like I have two things here. I have a squared and a 5th root. So I need to do the inverse of both of those. So the first thing I'm going to go ahead and do is I'm going to take the inverse of squaring. I'm going to square root both sides. When I square root both sides, the square and the square root cancel each other out, and I'm left with the 5th root of x equals the square root of 4. Remember, when we square root or even root, we have a plus or minus. So plus or minus 2. And now what I can do is I can get rid of that 5th root by going ahead and saying, well, I can take everything to the 5th power. The 5th root and the 5th power cancel, and I'm left with x equals 2 to the 5th power is 32 with my plus or minus. Now, what I would do to make sure this works is I would type it into my calculator. 32 to the 2/5 power. Okay, that's going to give me 2 squared, which is 4, because I'm going to do the 5th root of 32, which is 2, square it, which is 4, and 4 times 3 is 12, and 12 minus 12 is 0. So the plus 32 works. Let's make sure the negative 32 works. The 5th root of negative 32 is negative 2. Aha, negative 2 squared. If I take a negative and I square it, I'm going to get a positive number. So positive 4 times 3 is 12, minus 12 is 0. So both of them do work. Okay, let's try one more. Okay, again, we have a rational, well, we have a fraction, and it looks kind of scary. So let's go ahead and rewrite this in radical notation. Remember, the 4 is the index, and the 3 is the exponent or the power. Okay, so I'm trying to get that alone. So I'm going to go ahead and add 1 to both sides. So I have the 4th root of x plus 2 to the 3rd power is equal to 8. So now what I'm going to do here is I am going to do the inverse of either the 4th root, or I'm going to do the inverse of the cube. I'm going to go ahead and do the inverse of the cube. So I'm going to cube root both sides, because I know the cube root of 8 is 2 using my handy dandy sheet. And remember, it's only positive, okay? Unless that was a negative 8, and then it would be negative 2. The square roots are what we get plus or minus from. Now, to do the inverse of the 4th root, I'm going to do the 4th power to both sides. I'm going to get x plus 2 equals 2 to the 4th, which is 16. And now to get that x alone, I can go ahead and subtract my 2 out, and I get x equals 14. And now I'm going to check that. 14 plus 2 is 16. Okay, and I could come down here and do it down here if it makes more sense to you. 14 plus 2 is 16. The 4th root of 16 is 2. 2 cubed is 8. 8 minus 1 does equal 7. So that does check out. All right, folks, thanks for taking good notes, and we will be ready to practice these when I see you again.